Okay, we're back. Now, let's take a look at this homework problem. One of the things about um, contracted length that I want you to know is we're just looking at the x direction. So when they ask for the diameter or how tall this is, it's going to be, so let's look at this problem. A cylindrical spaceship of length 36 meters, so that's what we're measuring, and a diameter of 8.1 meters, or a height basically of 8.1 meters. So I know that this, I just don't want you to get messed up. If we were measuring this at an angle, then we'd have to do all kinds of trig things with the gamma function and stuff like that, which just gets kind of hairy. If you want to do that kind of stuff, feel free to take Modern Physics 350. You can play with those, and it's a good exercise. But so here we go. First of all, so let's see if that's right. So it's 8.1, right? So it didn't change. But what's the length of the ship as measured by an Earth observer? Okay, so we want to find the contracted length. It says a cylindrical spaceship of 36 meters. So that's the proper length. That's L naught. And we've already answered part B. And it passes by the Earth at a relative speed of 2.34 times 10 to the 8th meters per second. First of all, I don't like that they did it this way. So what's the first thing we're going to do? We're going to get this as a percent of the speed of light. All right. So that's what we need to do. The first thing we need to do is, so L naught, let's write down the information we know is 36 meters. Okay. And the speed was 2.34 times 10 to the 8th divided by 3.0 times 10 to the 8th meters per second for the speed of light. Meters per second per speed of light, so therefore the speed of the c goes up here. And so let's just take 2.34 divided by 3, and we get 0.78, okay? 0.78 c, all right? And they want us to find L. We already found D. That was the 8.1 meters, so we're not worried about that. And so L, well, that's not going to be hard. There we go. So L is going to equal 36 meters divided by the gamma function. And you all know how to find the gamma function. Okay? You all know how to do that. So that wasn't too bad. Maybe I should pick a harder problem. No. How long does it take to travel a distance 8 kilometers according to the ship's... Okay, so now here's where it gets kind of tricky. Okay, so how long does it take... Notice, this is difficulty 3. Most of these problems are. How long does it take? Now, we've talked about this. Oh, this is so much fun. All right, so how long does it take the spaceship to travel that distance according to the ship's pilot? So the ship's pilot, what time is he focused on? What's his time? His is the proper time. Okay? Now, you found out. So let's look at our relationships, our equations that we had. All right? So... you found the contracted length. We know the velocity, okay, is equal to delta T naught. We might have to leave that velocity in meters per second. This is very annoying to me. But we needed to convert it so that we could get the gamma function so we could solve this. But now we're probably going to have to put it back because, well, how do they want the answer? In microseconds. So whatever we wind up with, we're going to multiply that by 1 million and get the correct answer. Okay. So I'll do part C, and then I'll leave part D for you all. Okay. And that'll end this part of the track. All right. So So what are we trying to find? We're looking at this guy here. So let's go back. So we know that L, which you found, L is equal to 36 meters divided by the gamma function, which is equal to 2.34 times 10 to the 8th meters per second times delta T naught. Okay, so whatever you got here, divide by this V here, because this is meters and that's meters. What was the gamma? Just out of curiosity. Let's figure out what gamma was. It's driving me nuts now. I got to find out what the answer is because yours will be different anyway. So I got to find out what the answer is. So I've got 1 divided by the square root. I put the parentheses square root of 1 minus 0.78 squared, close, 1.59. Let's go with 1.6. Since it's 1.598, let's go with 3 sig figs. Let's go with 1.60. So gamma was equal to 1.60. Okay. So the contracted length then, L, is equal to 36 divided by the answer there, which is 22.5 meters. Okay, and so V, so delta T naught is equal to 22.5 meters divided by 2.34 times 10 to the 8th meters per second. Divided by 2.34 second e to the 8th. Woo, 9.6 times 10 to the negative 8 seconds. Multiply that by 1 million. 1 second e to the 6th. Or you could divide it by, and I get 0.096 seconds, milliseconds. Or 9.63 times 10, 9 points to the negative 2 milliseconds. Microseconds. Micro. My bad. All right, so here we go. Let's see if that's right. Drum roll, please. Oh. Uh-oh. Ruh-roh, Rorge. Okay, this is a good time to take a break and we'll come back.